Hello, I am Sudarshan there. Today I am going to discuss about the topic that is work, most important topic in physics. Let's begin. Now, what is work exactly? Work is defined as a force acting upon an object to cause displacement. Now, just remember what we are defining work it as a force acting upon an object to cause displacement. ऐसा फोर्स जो ऑब्जेक्ट पे एक्ट होने वाला है जिसकी वजह से डिस्प्लेसमेंट होनी चाहिए, एक जगह से दूसरी जगह जाना चाहिए. Displacement should be there upon action of force. This is called as work. So force acting upon object to cause displacement is called as work. Now how it is expressed mathematically? It is expressed a product of force and displacement, and that too in a direction of force. Just remember, displacement and displacement is a vector quantity, force is also a vector quantity, but the direction, it should act in a direction of force. Displacement should be action should be in a direction of force, then only we consider it as a work done. That is, W work done is product of force and displacement, F into S, where W is the work done on an object, F is the force on object, and S is displacement of the object. Unit of work is, now what is the unit? That is Newton meter or joule. Unit will be force, it is measured in Newton, the displacement is measured in meter. So as a combination, that is product, that will Newton meter, or it is also known as, or it is normally recommended and called it as joule. Work is measured in joule. So how can we define now what is 1 joule? 1 joule is defined as amount of work done by force of 1 Newton and displacement of 1 meter. So force of 1 Newton, displacement of 1 meter. When it takes place, then we call it as a 1 joule of work is done. Now what are the sign conventions? Normally just remember, in physics, normally in general cases we consider work is done. But in case of physics, we have to consider whether work done is positive, it is negative, or it is zero. Now these are the concepts where sign conventions regarding work done is considered. Now what are these conventions now? If displacement is in a direction of force, if force and displacement are in same direction, then work done will be a positive. Just remember, displacement and force, they should be in a same direction. Work done will be positive. Now if displacement is in a direction opposite to force, just remember, displacement and force, they are in opposite direction, then we'll call it as work done as negative. Work done will be negative. That will be minus F into S. Here negative sign indicates that they are in opposite direction. That is why negative minus sign is used. And second case, if displacement is perpendicular, work done is zero. Just remember, force is also there and displacement is also there. But if they are perpendicular, that means they are in 90 degrees. Then we call it as a zero work done. No work is done. Work done is zero. This is more amazing. Both are present. Product is also there. But if their direction is at 90 degrees or both of them are perpendicular, then work done in this case where force and displacement are perpendicular is zero. Zero work is done. I will explain it next how actions takes place actually. In this case, just remember, force acts on a body at an angle of theta direction. Now this is the force, this is the direction of force, and this will be a straight line. If this is the angle theta and this is the direction of force, what, and this is the displacement, that block, this block moves from this position to this second position, and the displacement is S. Just remember, what is displacement? Displacement is S. Then the two components normally act. One is F sin theta, upward direction, and second is F cos theta. Now this F sin theta is balanced by the gravity that is acting in downward direction. Okay, this will be acting. So it is, they comes in equilibrium. They are in equilibrium. As a result, what is left? The left part is F cos theta. So in such case, when force acts in a specific direction theta, then we call it as Fs cos theta. Work done is measured with a formula called as Fs cos theta. This is what the part is. Now if force and displacement are inclined at an angle less than 180 degree, just remember, angle is less than 180. This total angle, if you consider this total angle or this total angle from this point particularly to this particular point, then just remember, okay, I will take one ball point. We will consider it as an angle from this particular point, just part. Consider this angle from this particular point to this particular point. What is this? This will be 180 degrees. Now, but this angle particularly, this angle what we have taken, it is less than 180 degrees. That is why we consider it as a Fs cos theta. What will be our formula we are using? That is Fs cos theta. If angle is less than 180 degrees, formula will be Fs cos theta. Now, why this work becomes 0? Just remember why this work becomes 0. If Fs cos theta, if we consider cos theta, then in such case